So in today's video we are going to provide a quick run through on LCM, fraction and simplification of algebraic expression. So let's take a proper example on how we can find the LCM of numbers. So remember, LCM simply means the lowest common multiple. The lowest what? Common multiple. So if we are asked to find the LCM of 3 and 4, we are asked to find the least number which 3 and 4 can divide without a remainder. So for us to find this number, you can easily guess and say, oh, 24 can be divided by 3 and 4. Yes, you are right. But is that the least number that can be divided by 3 and 4? Absolutely no. There's a simpler number, and that's what we're going to look for in this very example. So for us to find the LCM, in our previous video, remember how we did it? We used the long division. So we have 3 and we have 4. So we draw a line here, and what we're looking for is the number that can divide 3 and 4 without a remainder. But there's no number. So we first divide 3 with 3. And when 3 divides 3, it gives us 1. But since 3 cannot divide 4 without a remainder, we bring 4 down. Next, we have to divide 4. And the number that can divide 4 is 2 and 4. So let's go simple. We have 2. 2 here, we already know is this column is completed. So 2 divide 4 is going to give us 2. So but this 2 still have to be divided further. So we can divide again by 2. And here we have 1. So 2 divide 2 is going to give us 1. So at the end of the day, the LCM we have is 3 times 2 times 2. And this will give us what? 12. So the LCM of 3 and 4 is 12. So let's look at the second thing we want to talk about, which is fraction. And fraction always work with LCM. So let's see. If we are asked to find or simplify this fraction, which says 1 all over 3 plus 2 all over 5 minus 1 all over 2. Now remember, we have to find the LCM of 3, 5 and 2. What is again is LCM? The least number which 3, 5 and 2 can divide without a remainder. So let's write them again. 3, 5 and 2. There's no number at the moment between the three of these numbers which can divide all through. So we can find the LCM by using this same method, but it is a bit easier since there is no common term here. We can simply multiply 3 times 5 times 2, and this gives us what? 30. So 30 is the least number which can be divided all through by these three numbers without a remainder. So let's simplify this fraction improper. Now that we know that the LCM is 30, we can now write 1 all over 3 plus 2 all over 5 minus 1 all over 2 to be, you bring down the LCM, which is 30 here, and then 30 divided by 3 is 10. You write down 10. Then you have this term at the top of 3, which is 1. You put it in brackets. You bring down this sign here, which is addition, 30 divided by 5 is 6. And you have 2 here, you bring it there. So you have negative sign here, you bring it here. And 30 divided by 2 is 15. So you write it like this. Next, we can now open this bracket. So 10 times 1 is 10 plus 6 times 2 is 12 minus 15 times 1 is 15 all over 30. So we can add up. So 10 plus 12 is 22 minus 15 all over 30. So this gives us 7 all over what? 30. Since we can't divide further, this becomes our answer. Again, let's look at the last one, the algebraic expression. So if we have this algebraic expression and we are asked to simplify 2x minus 4 all over 3x plus 5x minus 2 all over 6x. Remember how we found the LCM of these terms here. We also do the same for this very algebraic expression. So we need to find the LCM of 3x and 6x. These variables, these two numbers, they are carrying variables. So the LCM of both of them will also come with a variable. When I say variable, I'm talking about x, because the value of x is not known. So the LCM of 6 and 3x is going to be 6x. Now, why is it 6x? It is because 3x can divide, that is, can divide 6x, and 6x can as well divide what? 6x. So the LCM common between the two numbers is what? Is 6x. So the LCM of this term now becomes what? 6x. So let's rewrite it. We have 2x minus 4 all over 6x, right? So let's see what we have there. So I already wrote the top part of it. So 6x divided by 3x is going to give us 2, and this is how we got it. So we have 6x divided by what? 3x. This x will cancel out, and 3 here is going to give us 1. 3 here is going to give us 2. So 2 over 1 is 2. So we have 2 here into this term at the top of the numerator. Correct? Now 6x divided by 6x is going to give us 1. Similarly how we did it here. So we have 1. If you want, you can write it, but you can ignore it. But I'm going to write it for the sake of those who may not understand. So we have 5x minus 2, and then we can now open this bracket. So 2 times 2x is going to give us 4x. Here is going to give us minus 8, and we're going to open this one, going to give us 5x minus 2 all over 6x. So let's turn a leaf. So we have we will now have to take like terms here. So 4x and 5x here is supposed to be a positive sign. So we have 4x plus 5x, then minus 8 minus 2 all over what? 6x, correct? So 4x plus 5x is going to give us 9x, and minus 8 minus 2 is going to give us minus 10 all over 6x. So this is the answer for this algebraic expression. But there is something. If you have this as an answer in objective question, it is correct. But if you are doing an objective question and you don't find this answer, you can simplify a bit further. So we can rewrite this term to be 9x minus 10 all over 6x. We can rewrite it to be 9x all over 6x minus 10 all over what? 6x. So we look at this term 9x and 6x. They have a common factor, something that can divide both of them without a remainder, and they both have what? Variables. So 3 can divide both of them. So if 3 divide 9x, for instance, if 3 divide both, we're going to have 3 here is going to give us 3, and 3 here is going to give us 2. So we have 3 all over 2 minus, since it's a constant 10 and we have a variable beneath, we cannot divide them, so we leave it as what? 10 all over what? 6x. So this also becomes an answer. So in an objective question, if you find this, it's correct. If you find this, it's correct. So in either cases, you might find one of these as your answer. So this is how we can provide solution to LCM problem, algebraic expression, and simplification of a fraction. So I'll see you in the next class where we'll talk about more algebraic expression.